Hello. Right, okay, this one was lesson 11 with volumes. And let's have a look. We went through volumes of all sorts of different shapes. Volumes. Okay, so start off with cubes. And the way to work out the volume of a cube, knowing that everything is the same size, it's going to be just as simple as, make sure the volume is working. If that was 4 centimeters on the bottom, all the sides of a cube are the same. So what we do is we do the width times the length times the height, and that will be 4 times 4 times 4. 4 fours are 16, 4 16s are 64, so that will be 64 centimeters, and now we've got a little 3 that tells us it's a cube. So width, length and height. So if we have a cuboid, then they're not all the same length, but it doesn't really make any difference. We can do 4 and 3 and 10, and everything is centimeters. So the volume equals the width times the length times the height. In any order, it doesn't really make any difference. So we've got 4. Let's do it the other way around. Yeah, let's do the width and the height and the length. So 4 times 3 times 10. 4 threes are 12 times 10 is 120 centimeters cubed. Now the first two bits there, the 4 times the 3, will work out that is the area of the end. Yeah, and that's important when we get onto different shapes. That's important. So let's have a look. Now let's do one of these. It's a cuboid, and this is a sort of puzzle that you might be asked. There, 3, 3, nothing's to scale, yeah. Now we've got another one, slightly different shape. Now these two, these two have the same volume, and we've got to work out what the height of the second cuboid is. So first of all, we work out the volume of this one. So the volume is 3 times 3 times 8. 3 threes are 9, 9 eights are 72. 72, we'll call it centimeters cubed. And now we know that 72 will equal 6 times 6 times the height. So that's 36, so we can go 72 equals 36 times the height, and just divide by 36, so 72 divided by 36 equals 2. So the height is 2 centimeters. So you just have a little bit of rearranging of the equation or the formula to work out the second one, and then what did we go on to? We went on to triangles. So we've got the triangle, and we'll have 8, 8, and we'll make this into a triangular prism. Okay, and we'll call that 20, and everything is in centimeters. So we need to find out the area of the triangle and multiply it by the length. So the volume is going to be half base height, which is the area of the triangle, times the length. So that's going to be a half times 8 times 8 times 20, and half times 8, or 0.5 if you want to put it in the calculator, 0.5. That's 4 times 8, 4 eights are 32. 32 times 20 is 64 with a 0 on the end. So that's 640 centimeters cubed. Now, let's have a look. So on this one, we're going to go down here with a cuboid, and the cuboid is going to be 4 times 16, and this one has got the same volume as the prism up there. So what is the length is the question. So the length, so this one. So we know that the volume of this cuboid now is 640 equals 4 times 16 times the length. 4 16s are 64 times the length equals 640. So now we do 640, getting down to the bottom, divide by 64 equals 10 centimeters. So the length is 10 centimeters, not to scale, of course. So then the next thing to do is we're going to use pi. Now, because we're going to go on to circles. Now, on your calculator there, right down the bottom, there's a button in the middle which has a little yellow pi symbol above it, and there's the display, and up here there is a shift. So when we want to do pi, we go shift pi, and the pi goes in the display there. So that's how to use the pi. Now here, somewhere in the middle, there is x with a little squared. So if we press that, we can square the number. So if we want to do 3 squared, we type in times 3, press that button, and we get a little square that appears. Right, so let's do a circle. So we're going to draw a reasonable circle on here. Whoops. A circle. Right. Now, let's revise finding the area, and we'll do 15 centimeters. So the area of this is pi r squared, which equals pi on the calculator times r squared, 15 squared. And that comes out as pi times 15 squared is 225. So if you wanted your answer in terms of pi, it would be equal to 225 pi. If you wanted your answer to a decimal, you just do the whole lot. Let's get the calculator. Bear with me. So we're going to go shift pi times 15 squared equals, and there is another button on here which is the SD button, and this changes from surds from 225 pi to a decimal. So press that button there, and we've got 706.686. And what's that? Centimeters squared. I've done that to 2 decimal places. Often asked for. So that's how to find the area of the end. Now, I come down a little bit. Yeah, come down. So if we're going to use that knowledge to find volumes. So we've got a cylinder. And the volume of a cylinder equals the area of the end, which is pi r squared, times the height, or times the length if it's on the ground, if it's lying down. So we'll make this 12 centimeters, and we'll make this 20 centimeters, the height. So the volume here is going to be pi times r squared is 12 squared times the height, which is 20, and that comes out in terms of pi is 2880 pi centimeters cubed, or as a decimal 9047.79 or thereabouts centimeters cubed to 2 decimal places. Nice and easy. Right, so we know how to work out the volume of a cylinder. We know how to work out the volume of a cuboid. So now we're going to have a cuboid like this. And I'll do the other side so we can see what's, make it 3D. And in the middle of the cuboid, we're going to make a hole. So we're going to find the volume, let's move up a little bit, yeah, find the volume of what's left after we've taken a hole out of the cuboid. So let's put some measurements on there, 5, 15, 20. So that's how to find the volume of the cuboid, and the diameter is 5 centimeters. Okay, so first of all we find the volume of the whole thing, then we find the volume of the cylinder, and we take one away from the other, and we will have the volume of the cube, of the what's left. Okay, so the volume of the cuboid is equal to 5 times 15 times 20, and that equals 1,500 centimeters cubed. Now the volume of the cylinder, which is pi r squared times the height. This is equal to pi times r, which is half of the diameter, which is 2.5 squared, times the height. The height of the cylinder is the same as the height of the cuboid, which is 5. And all that comes out to is 98.17, I'll call it, centimeters cubed. And to find the volume of the block of wood that's left, we're going to do the whole thing, 1500 minus 98.17. And that will equal about 1401.83 centimeters cubed. So you're finding one from the other. Now, so more on cylinders. So we have a cylinder like this, and in the cylinder we have, let's go on to the back. In the cylinder we have made a hole of another cylinder. Whoops, not very straight, yeah, another cylinder. So we've got a sort of a ring type shape. Imagine you had a tube of steel or something, and that's a hole in the middle. There's the top, and so we've got a big cylinder with a hole in the middle. We want to find out the volume of the shape minus the hole, of course. So let's do the diameter there of 3 meters. It's quite long, this, isn't it? So 7 meters tall and 6 meters across. I think that's enough to find out. So the volume of the hole is going to be equal to pi r squared times the height, which is pi times r squared. Remember, it's half of this, isn't it? So it's 3 squared times 7. So this is 197.92 meters cubed, and the volume of the hole is going to be pi r squared times the height, which is pi r squared, which is times 1.5 squared times a 7 again, and that comes out as 49.48, more or less, meters cubed. And so to find the volume of the ring, I call it a ring, it's going to be this one at the top, minus that one. So we got 197.92 minus 49.48. See what that comes out as. So we got 4, 4, 8, 4, 1. 148.44 meters cubed. Right. Now, the next thing we worked on was pyramids. So here's a pyramid. Now, if you put a pyramid inside a box that has the same, I'm going to do this, so that there, oops, a bit wonky. Now imagine this pyramid is inside a cuboid and the volume of the pyramid is exactly 1/3. 1/3 of the volume. Let's do it in blue so we don't mess up. So the volume of a pyramid is 1/3 the volume of the cuboid. So we've got this 1/3 times the area of the base, which I'm going to do width times length times the height. So that width, length, height is how you find the volume of a cuboid, but it's 1/3 of it. So if we've got this is 10 meters and 10 meters, and what can we call the height? 15, because that divides by 3, so we should be okay. So this is going to be 1/3 times 10 times 10 times 15. So I'm going to do a, or you could do it this way, 10 times 10 times 15 and divide it out by 3. Multiplying by 1/3 and divided by 3 is exactly the same thing. So this comes out as I'm going to do that divided by 3, which is 5. So 10 times 10 is 100 times 5 is 500 meters cubed. Now it could be that they give you the volume of a pyramid and ask you to work out maybe the height or something like this. So if we say the volume of this is equal to 1800 centimeters cubed, and this is 30 centimeters by 30 centimeters, so what's the height? And of course it's vertical height. Yeah? So let's put in what we know and into the formula. So the volume is equal to 1/3 times 30 times 30 times the height, and we can replace the volume with 1800 is 1/3 times 30 times 30 times the height. So let's work all this out. So this is 1/3 times 30 is 10. 10 times 30 is 300. So we've got 1800 equals 300 times the height. Now take the 1800, divide it by 300, which 3's into 18 goes 6. So it's 6 centimeters the height. Right, so the next bit we did was a cone. Now again, if you take a cylinder and you put a cone inside it, then the cone is 1/3 the volume of the cylinder. So the volume of a cone is equal to 1/3 times pi r squared, that's finding the end, times the height. So let's have a look at a cone calculation. So these cones can be upside down as well, just to make life difficult. So we're going to say the height is 12 centimeters and the radius equals 4 centimeters. So the volume is equal to 1/3 times pi r squared height. I don't need to put the times in there, but anyway, it's 1/3 times pi times 4 squared. 4 squared is 16 times 12. So I'll have to do that on the calculator. So 1 divided by 3 times pi times 16 times 12 equals, comes up as 64 pi centimeters cubed. And if I press the SD button, it's 201.062 centimeters cubed. Right. Now the last bit of this, the last shape of this lesson was something called a frustum. Now a frustum is a sort of old lampshade shape. Now if we take a cone and we cut the top of the cone off, we are left with that shape, and that is the frustum, and we've got to work out volumes of the frustrums. So in order to find the volume of the frustrum, we would have to work out the volume of the large cone, so the large cone, and minus the small cone. Yep. So if we work out the volume of everything and then work out the volume of the little bit at the top, take it away, we're left with the volume of the lampshade frustum bit at the bottom. So here is the height of everything, which is 10, call it all centimeters, yeah? And here is the height of this bit, which is 5, and the radius here r equals 2, and the radius here r equals 4. Now, first thing to notice that this circle, the bottom of the top cone, is exactly halfway up, and the radius is exactly half of the radius at the bottom. So there is a sort of proportionality thing. Depending on how far up we go, is it going to be, we can determine what the radius is, and we'll look at that in a minute. Yeah. And so let's just work out the volume of the frustum. So the large one is going to be equal to pi r squared times the height, and a third, yeah, because it's a cone. So it's 1/3 times pi times r squared. 4 squared is 16 times the height is 10. So 1 divided by 3 times pi times 16 times 10 equals, do it in decimals, 167.55 what is it, centimeters cubed. And the small at the top, exactly the same formula, 1/3 pi r squared height equals 1/3 times pi times r squared. Now is 2 2s are 4, and the height is only 5. So we've now got 1 divided by 3 times pi times 4 times 5 equals 20.94 centimeters there. So now we define the frustum. we do 167.55 minus 20.94 and see what that is. 1 6 6 4 1 14661 centimeters cubed. The volume of a frustrum. Okay, so think about these relationships between the size of the diameter and the size of the, or the size of the radius, sorry, and the height of the thing. So now we look at something that they might add on to you, that if you have a cone like this, and up the top you've got a little one there, so you've got a radius there and a radius there. Now if the whole height is 100 centimeters and this little height here is 40, and you're given that this is 5 centimeters radius, and you've got to work out the volume of the frustrum, but they haven't told you what the radius is up there. So use these numbers here to work out what it is, yeah? So 40 over 10, over 100, sorry, and then multiply that by this one here. So it's 4/10 of 5. So 4/10 of 5. So I'll just do that on the calculator. 40 divided by 100 times 5 is 2. So it equals 2. So this now equals 2 centimeters. So we use the sort of ratio between the heights to find the radiuses, or you can do it the other way around, can't you? If you knew the whole height was 100 and you knew 2 and 5 but you didn't know 40, you could just go 2 over 5 times 100 equals 40. So you can find the missing height or the missing radius. So let's work out the frustrum. So the whole cone is going to be equal to 1/3 pi r squared times the height, which equals 1/3 times pi times r squared is 5 squared, 25, times the height is 100. And let's find out what that is. 1 divided by 3 times pi, press the wrong button, 1 divided by 3 times pi times 25 times 100 comes out as 2617. So that equals 2617.99 centimeters cubed. Now the small cone, again 1/3 pi r squared height equals 1/3 times pi times r squared. Now this is 2 squared this time, and the height is 40. That's what we had to find out before. So 1 divided by 3 times pi times 4 times 40 is 16755, 167.55, more or less, yeah. And 6755, and to find the frustrum, it's 2617.99 minus 167.55, and that's going to be 4405, 542 centimeters cubed. All right, okay, let's do a last one. Another frustrum, this time it's upside down. But don't worry, it's exactly the same thing. So we've got a little bit down the bottom there and a big bit at the top there. So this radius equals 35. This radius we don't know, but we know that that is 10 centimeters, and all the way is 50 centimeters. So we need to find the radius of the small bit there. So let's find out. 10 divided by 50 is this, divided by that, the heights, and then we multiply that by 35. So it's 1/5 of 35, so 35 divided by 5 equals 7 centimeters. So now we've found out that that is 7 centimeters R. Right, so the small, I'm doing it the wrong way around now, but it doesn't matter, is 1/3 pi times the radius squared is 49 times the height is 10. So 1 divided by 3 times pi times 49 times 10 equals 513.13 centimeters cubed. And the big one, the whole, equals 1/3 times pi times the radius squared, 35 squared times 50. That's going to be a big number. So 1 divided by 3 times pi times 35 squared times 50 is 64140.85. And if I type in 64140.85 minus 513.13, I get an answer of the frustum is equal to 63627.72 centimeters cubed. So that's how to work out frustrums, and that's grade 6 questions. Okay, I'll stop that one.